All right, time zones. I think we all understand the basics of, each time zone is what we use to set our clocks. What zone you're in is what clock you're using. And I think we, of course, know that the sun rises in the east and sets in the west, which means that over in the eastern hemisphere or in anywhere east of your position, their clock will be set to a later time because the sun has already risen for them, whereas for you, it might still be early morning, and then it moves across. But how exactly are these defined? How far apart are they? Well, we're going to have to do a little more fractions. How many degrees is the Earth's circumference longitudinally? How many degrees of longitude are there? Well, we've got 180 one way and 180 the other way, so we come out to a total of 360. That's crazy. It's almost like it's a circle. Okay, so the Earth is 360 degrees in longitude. Now, how much time does it take for the sun to rotate around the Earth? I know the Earth is the one spinning, but we'll get into this with SELNAV more. You have to take a heliocentric or geocentric view of the world. So we're going to say, how long does it take the sun to rotate around the Earth? A whole day, 24 hours. So the sun moves 360 degrees in a total of 24 hours. So how far does it go in 1 hour? 15. The sun moves 15 degrees of longitude in a single hour. And that is what we use to set our time zones. The prime meridian, the 0 time zone, GMT, UTC, whatever you may call it, it's the one that passes through Greenwich, England. And then every other time zone is simply just intervals of 15 degrees away from it. So here we've got 15 west, 30 west, 45 west. And over here we got 15 east, 30 east, 45 east. Now this is helpful if you're literally directly on 15 west or 30 west or 30 east or whatever. But what if you fall somewhere within one of those time zones? Well, these are the centers of a time zone. These meridians here, they're technically called the central meridian of their respective time zone. So they're not the borders, they're actually where they're defined off of. Meaning if you take split them down the middle, you get 7.5. And that's the border between every single time zone. So GMT technically exists from 7.5 west to 7.5 east. This time zone here, based off of 15 west, I'll get to its name in a second, it goes from 7.5 west over to 22.5 west. Now, like I said, what do we call this? Well, this time zone here is one time zone west of Greenwich, meaning the sun will rise for Greenwich 1 hour earlier. So if you were to convert your clock from this time zone to Greenwich, you'd have to add an hour on. And that's how we write it out. We write the zone description, it's called, as what you need to do to get your time to Greenwich time. So this would be ZD plus 1, because if it's 8 a.m. here, it's 9 a.m. in Greenwich. This is ZD plus 2. You need to add 2 hours to convert your time to GMT. Over here, we got ZD minus 1, because you're actually earlier than Greenwich, so you have to subtract an hour to get what the time in GMT is. ZD minus 2, ZD minus 3, and again, this is referred to as GMT, ZD plus 0, I suppose, UTC, I think Zulu, anything of the sort. There's a lot of names for Greenwich time. But what is important for you to understand is that every time zone is defined by a meridian and 15 degrees away from the previous time zone set off of the Greenwich meridian. And then their zone description is written as what you need to do to take the time in that zone and convert it to GMT time. Now, how do you figure out what time zone you're in? irregardless of, you know, whether you're using daylight savings time or anything. We'll get into that in a second. But how would you find out, like, let's say you're here. How do you know what your time zone is? Well, in this one, you can just see that technically you fall within ZD plus 2. But if you didn't necessarily know that, there's still a pretty easy way to do it. Like we said, every time zone is defined off of 15-minute intervals. So if you take your longitude and divide it by 15 and then round that to the nearest whole number, you should be able to get your zone description. So judging from this one, let's say we're 27 degrees west. Okay, you go to your calculator, 27 divided by 15. The answer is you can't see, but it's 1.8. So this is technically 1.8 time zones to the west of Greenwich. Well, 1.8 rounds to 2, so you can assume you're in ZD plus 2. Let's say go way over here, 153 degrees east. Well, you take 153, divide it by 15, you get 10.2. So this is technically 10.2 time zones to the east of Greenwich. So we can assume that that falls within ZD minus 10. And so on and so forth. If you have something like, let's say, 36 degrees and 14 minutes east, well, then you're going to have to convert the 14 into decimals of a degree to be able to then do this problem. So you would do 14 divided by 60, gets you 0.23 repeating. Add 36, so you get 36.23. Divide that by 15 finally, and you get 2.4. So 2.4, if it was 2.5 and above, you'd end up in minus 3, but it's just below the threshold, so you're right on the edge of minus 2 and minus 3, but you're on the minus 2 side. So you would be in ZD minus 2.